ships of that day all the way to China by crossing basically the Atlantic Ocean. And so had North America not been in the way, right, Columbus would have died, because there's no way they could have made it all the way to China, right? So yeah, that was the deal with Columbus. It wasn't the round Earth, it was the size of the Earth. In fact, it's really interesting. I mean, there were Central Asian thinkers living at 1000 AD who very precisely calculated the circumference of the Earth and hypothesized the existence of North America. Basically, Al-Biruni, I think, was the guy who said, look, there's almost certainly that distance between this coast and that coast is so large, there's probably a landmass in between, and there's probably people living on that landmass, and in principle, we'll eventually go there. So there were a lot of people who even knew that there's probably a landmass there. So that story that's a whole story in and of itself. Anyway, great question. Okay, so we get to Copernicus now. So in around 1543, actually, at the very end of his life, Nicholas Copernicus published this idea. Now, he was a Polish priest, and the thing that was very interesting about Copernicus is he was one of the first people to have his own library. Okay, the printing press was just kind of coming into existence. Paper had made its way to Europe, and it was getting to the point where private individuals could actually have their own libraries to study in. This was a totally new kind of thing, right? Before you had to go to these vast centers of learning that had books and scrolls, and you would learn from them. He had his own library. He was really educated. He educated himself and was aware of a lot of this stuff. He was aware of the ideas of Aristotle and basically his enemies that thought he was wrong about the Earth being the center and not moving, etc. He knew, by the way, that Ptolemy's predictions were inaccurate in some ways. And he thought that Ptolemy's model was basically ugly. And he thought it would be much prettier to put the sun at the middle. And he knew that if he put the sun at the middle and had everything going around the sun, this could account for retrograde motion just as well as Ptolemy's model could. And I'll show you that in a second. But the problem was that when he did this, when he put the sun at the middle, he made all the planets orbit the sun on circles. He put this whole thing together, and what he found is this didn't match the data either. And in fact, it did no better than Ptolemy. And this is probably why he waited to the very end of his life to publish his book on the revolutions of the celestial spheres, where he introduced this idea. Now, eventually, this Copernican idea would change the world, but it took a long time for people to accept it. There were feuding factions among the sort of proto-scientific community at the time. Some people liked it, some people didn't. But it did account for this retrograde motion in sort of a natural way. It's basically in the same way that if you're on the inside track, like the Earth, and you've got an outside planet orbiting the sun, sometimes you overtake them. And when you do that, you're first looking forward at them, and then when you overtake them, you look back. And so that's basically what's going on with the retrograde motion. Now, like I said, there's ideas of whether some people accepted it, some people didn't accept it. Interestingly, the English astronomer Thomas Digges was one of these heliocentric proponents. He liked the Copernican pictures. But he actually got rid of the whole idea of celestial spheres entirely. So Copernicus had the stars still out there on a celestial sphere. Thomas Digges said, well, now we've got this going on, let's just think of the other stars as distant suns. We'll get rid of the celestial sphere. All those stars are distant suns. And the reason why some stars are bright and some stars are dim is that the bright stars are nearby and the dim stars are far away. Really kind of saved the day. So Johannes Kepler was a mathematician who was living around the year 1600, and he was working with data that was taken by another famous astronomer named Tycho Brahe. But what Kepler did is he said, look, the reason why this Copernican picture doesn't work, the reason why Copernicus' model of explaining where the stars and the planets should be in the sky at any given night is wrong, is because he's still stuck on this old Aristotelian idea that everything has to be on a circle. It doesn't have to be on a circle. And he put them on ellipses. He said, look, if you just make planets orbit the sun on ellipses, then everything works. And as soon as he had this realization, he broke out of this idea that everything had to be a circle. Suddenly, this Copernican idea where the sun's at the middle, everything now orbits the sun on ellipses, suddenly that works. Everything is taken care of, and we can start explaining the data incredibly well. So for the really sober-minded people living at this time, this was probably enough to convince them that this model was better than Ptolemy's. But again, there was this whole idea of parallax that nobody could see. In fact, Kepler's boss, Tycho Brahe, who was not a Keplerian, he thought for sure the Earth was fixed. And that's because he regarded himself as the greatest astronomer who had ever lived. He went out to look for this parallax and he could never see it. And so he was on the side of Aristotle and said, look, the Earth is not moving because I can't see the parallax shift of the stars. So it's sort of debated. And this is how science works. People have an idea, people debate it, what about this, what about that, and the conversation develops from there. The final sort of nail in the coffin of the Ptolemaic/Aristotelian idea of what the solar system looks like came to us from Galileo Galilei. So Galileo was really an incredible kind of polymath type of scientist. He did lots of things, was really fundamental stuff in the very beginnings of physics. But the thing he's most noted for in astronomy, and maybe most noted for in general, was that he was the first human being to take a telescope and point it up at the sky. Now, the telescope was invented not by Galileo, but he heard about it. People had figured out that if you took two different kinds of lenses, okay, people were developing, it's a really interesting story, so people were developing lenses, people were starting to develop lenses in Europe. Why were they doing that? Because suddenly there were books in Europe that people were trying to read, and suddenly people realized that they were farsighted and they needed eyeglasses. So there became this huge industry for people to build lenses. So people started figuring out how to build lenses, and some of the people who were playing around with lenses realized that if you put two of them together and line them up in a certain kind of way, you could see stuff that was farther away than you could otherwise see. So the Dutch basically invented telescopes. Galileo heard about this and said, that's a good idea. I'm going to invent a better one. And he did. And instead of taking those telescopes and pointing them out to sea to look for ships or pointing them in his neighbor's bedroom window to see other things, he looked up at the sky.